Right, question 5 on this. Okay, we have a cube. If I can draw a cube on here. All sides are the same on a cube, okay? All the sides are the same. There we go. Right, in terms of x, right, if this, say, width is x, or the length is x, you know, the height is x, so don't forget what volume is, length times width times height. So x times x times x, so x times x times x is x cubed, okay? It's like saying x1, 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 you would add exponents. But there's I don't think of this, I know simply there's 3 of them. It's not 3x, that is 3 times x. X times x times x is x cubed, okay? Now, all of a sudden we're going to say that the length of each side is tripled. So all of a sudden it becomes 3x for the width, 3x for the length, and 3x for the height. So all of a sudden we've got 3x times 3x times 3x. Okay, well that becomes 27. 3 times 3 times 3. Again, still x cubed. All these like saying little x1s, just x times x times x, just like the first part. No change in that exponent, okay? But can you see that the actual volume of the triple cube now is 27x cubed, all right? So it's actually 27 times bigger. You've actually only made the length, the width and height 3 times bigger, but the whole thing becomes 27 times bigger, okay? So there you go, that's that one. Let's sneak over to this side. I don't get dizzy. Right, let's go up here. Find the area of each section A, B, C and D, then write an expression in simplest form that represents the entire area of the figure. So find the area of each section. So here we go. Right, area is, you know, length times width. So it's that, for this A, I'm just doing A right now, so that's the dimensions of A. It is x times x. I'm going to write it right inside. X times x is x squared, okay? That's what A is. Okay, B has got a width or a length of 3, but it's still got this, you know, this height, width, whatever you want to call it, of x. All right? So, B is going to be 3 times x, which is 3x. Okay, the length times the width, the 3 times the x. Right, C, okay, has got, I'll do it here. Remember, this is still x. Okay, that is still x on the top. It's got this, that's 2, so the length times the width is going to be 2 times x, which is 2x. And finally D. D, can you see, is still going to be 2. Right, it's 2 here. This on the bottom here is the same as this at the top here, which is 3. So 2 times 3 equals 6. Okay, so those are all the little individual rectangles, squares that make up the big one. So of course, to make the final area, I'll add everything up. So let's have a look. So I know I could have put them all here, but let's just look at the diagram. Okay, we have an x squared area. We've got a 3x, that's B. C is 2x, I'll add that to it. And D is 6. Okay, that's an x. So I can add all these together. Remember, you can add the, oh, sorry, plus, not equals, plus, plus. All right. So I can add the 3x and the 2x, that gives me 5x. So the total area of the whole thing is x squared plus 5x plus 6. Okay, there's nothing to add to the x squared or the 6. I could just do those two in the middle, okay, to make 5x, and that's it.